Imagine sitting here now, your body anchored to this chair. The rough texture of its surface beneath your fingers, the sound of your breath filling your ears, and the memories flooding back from just a few hours ago. This morning, you might have woken up with sunlight streaming through curtains, birds chirping outside, or perhaps you were already deep in the routine of another day. But what if every single detail of this moment, the chair, the breathing, the recollection, is nothing more than an illusion crafted by chance? What if all your memories are a series of electrical signals that happen to coalesce into the semblance of a life lived? The idea is unsettling. Consider those billions upon trillions of neurons firing in your brain right now, each one just a spark of electricity passing through. If those sparks could somehow be replicated by random chance in an otherwise empty void, you wouldn't be different. Your entire history would be identical to what it's supposed to be, yet everything about it would be false. Why does this happen? Why is the universe seemingly more inclined to create a single brain out of nothing rather than forming even one galaxy filled with stars and worlds? It seems counterintuitive, doesn't it? After all, shouldn't chaos lead to more chaos? Shouldn't disorder spread everywhere? To understand why this paradox arises, we must venture back in time to the late 19th century. A man named Ludwig Boltzmann was grappling with a problem that seemed impossible to solve. He was trying to explain entropy, why things always move from order to chaos, and he faced fierce opposition for his ideas. Yet his work laid the foundation for understanding not just how disorder spreads, but also how it can sometimes give way to fleeting moments of order. Boltzmann's life was marked by both brilliance and tragedy. He proposed that entropy, the measure of disorder in a system, would always increase over time unless energy is added from an outside source. Imagine breaking a glass on the floor, the shards spread out, increasing the overall entropy of the room. But this is just one side of his theory. What Boltzmann also recognized was that while order tends to give way to disorder, there are rare instances where chaos can momentarily organize itself. A storm might create unique patterns in sand dunes, or ice crystals could form intricate structures even as they melt away. These moments are fleeting and improbable, but according to Boltzmann's mathematics, they must exist somewhere in an infinite universe. Now let's zoom into the specifics of his theory. The second law of thermodynamics states that over time, everything moves towards maximum entropy, the state where no energy can be used to do work anymore. It's like watching a cup of hot tea cool down and eventually reach room temperature. It doesn't go back to being hot again on its own. But here's the kicker. If you wait long enough in a system that is completely chaotic, even extremely unlikely events must occur by sheer chance. This concept is known as Poincaré recurrence. In an infinite timeline, every possible arrangement of atoms will eventually come to pass. Imagine trillions upon trillions of years passing. At some point, the exact configuration of particles necessary for a forest to spontaneously grow in a desert would happen. This brings us back to our initial question. Why is it easier to imagine one brain appearing out of nowhere than an entire universe filled with galaxies and stars? The answer lies in probabilities. Creating a single human brain requires far fewer resources compared to forming billions upon trillions of celestial bodies over billions of years. The chance for the simpler event to occur is astronomically higher. But this leads us to one of the most profound and terrifying implications of Boltzmann's work, the likelihood that you might be a lone, transient brain floating in an endless void rather than a complex organism born from billions of years of cosmic evolution. The idea defies our common sense but aligns perfectly with the mathematics. You're not just watching this video, you are merely a cluster of neurons flickering into existence in a dark and cold universe that is already dead. Every person you've ever loved, every memory you hold dear, those faces and those moments are nothing more than pre-installed data patterns within your temporary mind. When the neurons stop firing, your entire world disappears back into the void from which it came. This is the horror of being a Boltzmann brain. You exist for only an instant before dissolving back into chaos as entropy reclaims its atoms. Yet despite this existential crisis, there's still something that keeps us going, the possibility that our thoughts might be real in some way. Even if we're just a fluke in nothingness, the act of thinking itself could hold a kernel of truth. So while the paradox remains, it also serves as a stark reminder of how little we truly understand about reality. It challenges us to question everything we think we know and prompts scientists to refine their models and theories continually. The Boltzmann Brain paradox may be terrifying, but it is also an invitation to explore deeper into the mysteries of existence. The chair beneath you cradles your body as you sit, absorbing the texture of its surface. Your morning routine plays out in vivid detail, the aroma of brewing coffee, the sound of flipping pages, the taste of a fresh croissant. But these sensations are fleeting, mere echoes of neural signals firing within your brain. If those electrical impulses could be replicated by chance in an empty void, all your memories and experiences would cease to have meaning, reduced to nothing more than an illusion spun from chaos. Imagine a universe devoid of stars, planets, or life, just endless darkness, stretching infinitely in every direction. Now picture the tiniest spark of energy forming into a single brain, complete with neurons firing in patterns that mimic your own thoughts and sensations. This bizarre scenario is at the heart of the Boltzmann Brain paradox. Why does it seem easier for the universe to create one isolated mind than an entire cosmos filled with galaxies, stars, planets, and life? The paradox challenges our understanding of reality itself by questioning whether what we perceive as our personal history is truly a record of events that have occurred, or merely a fabrication conjured from random fluctuations in the vacuum. Ludwig Boltzmann, a 19th century physicist, grappled with these questions long before they were articulated. His work on entropy, the measure of disorder in a system, paved the way for contemplating such mind-bending scenarios. He proposed that over vast stretches of time and space, even highly improbable events might happen by sheer chance. Entropy dictates that systems move towards states of higher disorder. A broken glass shatters into pieces because there are more ways for those pieces to be scattered than neatly assembled. Similarly, the universe should naturally decay into a lukewarm soup devoid of structure or complexity. Yet here, we find ourselves amidst intricate galaxies and diverse life forms. Boltzmann's radical idea was that, given enough time, even an entirely chaotic environment could produce ordered structures through sheer randomness. A forest might spontaneously grow in a desert if you wait long enough, trillions upon trillions of years for this unlikely event to occur. This principle, known as the fluctuation theorem, suggests that order can emerge from chaos not because it's inherently destined to do so, but purely due to statistical probabilities. The mathematics behind these concepts is staggering in its implications. The Poincare recurrence theorem posits that given infinite time and space, every possible arrangement of atoms must occur eventually. This includes the formation of a single brain out of random particles, a thought process far more energetically favorable than assembling an entire universe. Why then do we observe such complexity in our observable universe? Why isn't everything just one vast cold soup devoid of any life or structure? The answer might lie in the incredible improbability and energy required to create a Big Bang scenario compared to the relatively cheap emergence of singular minds from chaos. A single human brain requires far less energy input than an entire cosmos teeming with life. This leads us to confront a disquieting possibility. You, as you experience yourself now, might be nothing more than a fleeting fluke in an otherwise cold and barren universe. Your memories, your existence, everything that makes you who you are is but a transient spark amidst endless darkness. The Boltzmann Brain paradox forces us to question the very foundation of our reality. Every sensation you feel, every thought that crosses your mind might be just as real as an illusion spun from random chance in a void. If this is true, then how can we trust any of our perceptions? How do we differentiate between what's truly happening and what could merely be a temporary delusion conjured by the chaotic dance of particles? Yet even within this paradox lies a glimmer of hope for understanding more deeply the nature of reality. By grappling with such daunting concepts, scientists are prompted to refine their models and theories continually, searching for ways to explain why we observe a structured universe rather than one governed solely by randomness. In essence, the Boltzmann Brain paradox challenges us not just to question our existence, but also to explore deeper into the mysteries of cosmology. It serves as both a terrifying reminder of how little we truly understand and an invitation to delve further into the quest for knowledge about the universe around and within us. The texture of your chair, the sound of your breathing, and the memories of what happened this morning. These are the building blocks of your reality. But what if I told you that these sensations could be just an illusion? What if everything you believe to be real is nothing more than a series of electrical signals firing in your brain? If those signals can be replicated by chance, then your entire history would be identical to a lie. Imagine standing in the middle of a vast desert. The only trace of life around you is a single tree that seems to have sprouted out of nowhere. This tree is like you, a temporary fluctuation in an otherwise chaotic and empty universe. According to the Boltzmann Brain paradox, it's theoretically possible for your entire existence to be nothing more than a fleeting momentary fluke amidst cosmic chaos. Why is it easier for the universe to create one brain rather than a billion galaxies? This question strikes at the heart of why we find ourselves in this complex and ordered cosmos. When you consider the sheer vastness of space and time, the probability of even a single neuron firing correctly by chance seems astronomical. Yet, somehow, life exists and consciousness is aware. The paradox forces us to confront the unsettling possibility that our universe could be governed solely by randomness. If this were true, then every moment of your existence might not be an unfolding story, but rather a series of isolated events that have no connection to each other or the past. The idea challenges everything we think we know about causality and continuity. To understand why this is such a profound paradox, we need to delve into the work of Ludwig Boltzmann, a brilliant physicist who lived at the end of the 19th century. Boltzmann's tragic life was marked by his struggle to make sense of the second law of thermodynamics and entropy. Entropy describes the natural tendency of all closed systems towards disorder. It is why broken glasses don't mend themselves, and it suggests that over time, everything tends toward a state of maximum randomness. Boltzmann saw this as an existential quandary for science. If every system in the universe must inevitably degrade into chaos, how do we explain the complex, ordered structures around us? How did life arise from such unlikely odds? To address these questions, Boltzmann proposed a radical idea. Even though entropy is always increasing overall, it's possible that within this trend of disorder, there could be local fluctuations where order temporarily emerges. For example, in a sufficiently chaotic environment, given enough time, a forest might just sprout from the desert sands. This concept has profound implications when applied to our understanding of consciousness and existence itself. If Boltzmann's theory holds true, then it becomes plausible that your entire mind could be nothing more than a brief, isolated fluctuation in an otherwise chaotic universe. Just as a tree might emerge unexpectedly from barren soil, so too could you appear out of cosmic chaos. The mathematics behind this idea is both staggering and disconcerting. Consider the principle known as Poincaré recurrence, which posits that in an infinite timeline, every possible arrangement of atoms must occur. This means that eventually, even if it takes trillions upon trillions of years, your exact brain could randomly assemble itself out of the cosmic soup. However, creating a complex universe like ours is astronomically more improbable than this. The paradox arises from comparing these probabilities. The formation of a single human brain appears far less energetically expensive and statistically probable compared to the creation of an entire cosmos with billions of galaxies and stars. If you were to consider the sheer complexity and improbability involved in creating such a universe, it would be akin to winning every lottery jackpot conceivable simultaneously. The logic of chaos suggests that while the emergence of life as we know it is exceedingly unlikely, the chance occurrence of even one conscious observer like yourself is more likely than we might initially suppose. The paradox thus challenges us to question our most fundamental assumptions about reality and existence itself. In the end, this thought experiment leaves us with a haunting possibility. You may be nothing more than a fleeting Boltzmann brain, a transient fluctuation in an otherwise dead universe. Your memories of love and loss, your deepest hopes and fears could all just be temporary patterns in your mind that will dissolve back into chaos as entropy reclaims its atoms. Despite the unsettling nature of this idea, it serves to remind us of how little we truly understand about our place in the cosmos. The paradox challenges us not only to question our existence, but also to deepen our understanding and exploration of the mysteries that lie at the heart of cosmology. We sit here now, aware of the textures around us, the softness of the chair beneath our body, the quiet hum of breath moving through lungs. The memories of this morning linger fresh and vivid, yet each moment passes into the past as surely as a river flows downstream. But what if those memories are not true? What if they're just fleeting patterns in a vast sea of random chance, no more real than the shapes clouds take on a summer day? Imagine for a moment that your entire life is an illusion, crafted from nothing but electrical signals firing within your brain. Those signals could theoretically be replicated by pure accident, even in a vacuum far removed from any material reality. If those signals were to emerge out of chaos and form your consciousness just now, then every single memory, thought, and feeling you've ever had would be identical to one born not of experience, but of chance. This is the crux of the Boltzmann brain paradox. Why is it easier for the universe to create one brain than a billion galaxies? It's a question that cuts deep into our understanding of existence. On the surface, it seems counterintuitive. How could something as complex and specific as a human brain arise out of nothing but chaos? Ludwig Boltzmann was a physicist who grappled with this paradox at the turn of the 20th century. His work on entropy, the measure of disorder in physical systems, revealed that over time all matter tends toward a state of maximum randomness. A broken glass cannot mend itself because doing so would decrease its entropy, moving from a state of disarray to order against the natural flow of things. Yet Boltzmann also proposed an intriguing hypothesis. If you wait long enough in a chaotic universe, random fluctuations will eventually create pockets of order, even if they're temporary. This idea, known as Boltzmann's fluctuations, suggests that a forest could spring up in the middle of a desert, or an intricate structure like a brain might form from scattered atoms, given enough time and space. The paradox deepens when we consider the scale of such fluctuations. Imagine all possible arrangements of atoms in the universe. Each combination is unique, yet most would represent states of maximum disorder. A Big Bang, which created our vast cosmos complete with galaxies, stars, planets, and life, requires an enormous input of energy and organization. It's a highly improbable event compared to the likelihood of just one brain forming out of chaos. This leads us to ponder the mathematics of such events. In a universe that exists for eternity, where time has no beginning or end, a principle known as Poincare recurrence predicts that every possible configuration of atoms must occur at some point, however unlikely. So in this infinite timeline, it's statistically more probable for a brain to form spontaneously than for complex biological life to evolve over billions of years. Thus, we're left with an unsettling conclusion. You might be nothing more than a momentary flash of consciousness in a vast and dead universe, your existence a fleeting anomaly amidst the overwhelming tide of chaos. The people around you, their smiles, their laughter, their shared moments, are not real connections but fabricated memories within your isolated mind. And yet, even as we confront this horror, there is a glimmer of hope. If we are indeed Boltzmann brains, our cognitive processes would be inherently unstable, incapable of trusting the very logic that led us to this conclusion. In essence, if you're just a brain in a void, then your ability to reason about your existence is flawed from the start. Scientists today use this paradox not as a definitive truth, but as a cautionary tale, highlighting potential flaws or limitations within our current understanding of cosmology. It challenges us to refine and expand our models, seeking explanations that can account for both the vast cosmos and the intricate patterns of consciousness that we perceive as real. In the end, whether you're a fluke in the void or an inhabitant of a grand universe filled with billions of years of cosmic history, the act of contemplating your existence itself holds profound meaning. The thought that arises from this paradox, no matter how unsettling, is a testament to our innate drive to seek understanding and meaning amidst the chaos. Ludwig Boltzmann, born in 1844 in Vienna, Austria, was not just another scientist. He was a prophet of decay, a man whose work would cast long shadows over our understanding of the universe and our place within it. Boltzmann lived during an era marked by rapid technological advancements and philosophical upheaval. His life's work was driven by a profound struggle to make sense of entropy, the relentless march towards disorder that governs not only machines, but also living systems and even human societies. In his early years, Boltzmann was captivated by the mechanistic theories of physics which dominated scientific thought during the 19th century. He saw the universe as a grand clockwork machine, governed by strict laws of cause and effect. However, as he delved deeper into thermodynamics, Boltzmann encountered a paradox. If the universe is indeed a deterministic system ruled by these laws, why does it seem to be unraveling towards chaos instead of remaining in equilibrium? This question led him to formulate the second law of thermodynamics, which states that the total entropy of an isolated system always tends to increase over time. Boltzmann's insight was groundbreaking. He argued that while local regions might experience fluctuations leading to temporary order, the overall trend for any closed system is towards increasing randomness and heat death. Imagine a broken glass on the floor. Once shattered, the pieces will never spontaneously reassemble into their original form due to the overwhelming statistical likelihood of disorder over order. This principle extends far beyond everyday objects. It applies to stars collapsing into black holes, galaxies dispersing their contents across vast expanses of space, and even the decay of human societies and civilizations. Boltzmann's struggle was not just intellectual, but also deeply personal. His ideas were met with skepticism and ridicule from many in the scientific community, leading him to feel isolated and misunderstood. He once wrote despairingly about his theories being like a child's snowball which melts away as soon as it is thrown. This alienation took its toll on Boltzmann's mental health, culminating in tragic suicide at the age of 62. Despite the personal cost, Boltzmann's legacy persists. His work laid foundational principles for modern statistical mechanics and quantum physics, but his core contribution remains the second law of thermodynamics. This law has profound implications not just for the physical sciences, but also for philosophy and our understanding of existence itself. It implies that order in the universe is transient and subject to relentless erosion. A broken glass might be an everyday occurrence, but consider a more cosmic example: the Big Bang. The initial conditions required for such an event are astronomically improbable compared to the likelihood of a single human brain forming through random atomic collisions. This stark contrast forms the crux of the Boltzmann Brain paradox, the idea that it is logically simpler and thus statistically more probable for a lone observer like you or me to emerge randomly from chaos than for an entire universe filled with stars, planets, and life as we know it. Boltzmann's radical solution was the concept of thermal fluctuations. He proposed that given enough time, trillions upon trillions of years, even in a state of maximum entropy, random atomic configurations could result in temporary pockets of order. Just like how a desert might spontaneously form a forest or ice crystals suddenly emerge from water vapor under certain conditions, Boltzmann suggested that intelligent minds could momentarily materialize within the cosmic soup. The idea is both staggering and unsettling. If all we have are electrical signals firing in our brains, then those same signals could theoretically be replicated anywhere in the universe at any time. This means that your memories of childhood, your experiences with loved ones, even your current moment, these could all be illusions generated by chance in an otherwise lifeless void. The implications of this thought experiment are profound and disturbing. It challenges our notions of reality, existence, and consciousness itself. If you're a Boltzmann brain, a fleeting spark of sentience amidst the cosmic void, then every person you've ever known is merely a pre-installed memory pattern in your temporary mind. The faces of loved ones, the warmth of human connection, all illusory constructs flickering into being for an ephemeral moment before dissolving back into nothingness. In grappling with these ideas, Boltzmann's work reveals a universe that is not only vast and indifferent, but also deeply uncertain in its fundamental nature. The second law of thermodynamics serves as a reminder of the transient beauty and fragility of ordered systems amidst the overwhelming backdrop of cosmic entropy. It prompts us to question our place within this grand tapestry, wondering if we are mere artifacts of chance or integral parts of a greater narrative. Yet even in contemplating such profound existential questions, Boltzmann's legacy offers a beacon of hope. His journey from isolation and despair to groundbreaking scientific insight underscores the human capacity for resilience and discovery in the face of seemingly insurmountable challenges. As we navigate our own inquiries into existence and reality, Boltzmann's life and work remind us that questioning the nature of the universe is not just an intellectual exercise, but a deeply personal and transformative journey. The man who would become a prophet of decay was born under an unassuming sky. Ludwig Boltzmann, a name now synonymous with entropy and the nature of reality, began his life in Vienna in 1844. As a child, he showed a remarkable aptitude for mathematics and physics, but it was the profound questions that haunted him, questions about the meaning and purpose behind the universe, that would set the course for his life's work. In an age when science was still struggling to define its place in society, Boltzmann's ideas were both radical and ahead of their time. He saw the world not as a fixed, eternal construct, but as a dynamic system governed by laws that could be understood and explained through mathematics. His early experiences with scientific inquiry were marked by isolation and skepticism from peers who clung to older theories. Boltzmann's intellectual journey was shaped by his interactions with other thinkers of the era, such as Ernst Mach, whose empirical philosophy challenged Boltzmann's theoretical inclinations. Despite this initial friction, their debates led to a more nuanced understanding of physics and its relationship to reality. Yet it was in the isolation of scientific obscurity that Boltzmann began to articulate what would become his most enduring legacy, the second law of thermodynamics. The second law is not just a statement about heat transfer or mechanical energy, it's a philosophical assertion about the nature of time and the universe itself. It declares that, left alone, any closed system will move from order to disorder, from complexity to simplicity. This law challenges the very notion of progress and purpose, suggesting instead a world moving inexorably toward entropy, a state of uniformity where no work can be done. But Boltzmann was not content with this bleak outlook. His genius lay in his ability to see beyond the immediate implications of entropy to its potential for creation. He proposed that even within this framework of inevitable decay, there is a possibility for spontaneous order to arise through random fluctuations. This idea that a forest could emerge from chaos is both radical and profound. The concept of fluctuation was revolutionary because it suggested that complexity in life were not just the result of purposeful design, but also an emergent property of the laws governing physical systems. Boltzmann's work on statistical mechanics provided a mathematical framework for understanding how large numbers of particles could give rise to macroscopic phenomena, including the formation of coherent structures like brains. Yet, in his own time, Boltzmann faced immense criticism and misunderstanding. His ideas were dismissed as heretical, and he struggled with personal tragedy and mental health issues that mirrored the existential despair found within his theories. The pressure of being a voice in the wilderness took its toll, culminating in a tragic suicide. Boltzmann's legacy is more than just equations and scientific breakthroughs. It's a testament to human resilience and the pursuit of knowledge despite overwhelming odds. His life story provides a stark reminder that challenging conventional wisdom can come at great personal cost, but also opens pathways for profound insight into the nature of existence. In exploring Boltzmann's work, we confront fundamental questions about our place in an indifferent universe. Is there meaning beyond entropy? Can order and complexity arise from chaos without purpose or intent? These are not just scientific queries, but philosophical musings that touch on the essence of being human. By understanding Boltzmann's struggle to articulate these ideas, we gain insight into the challenges faced by those who dare to question established truths. Boltzmann's contributions to thermodynamics and statistical mechanics have since been recognized as foundational in modern physics. His legacy is a reminder that even in the face of despair and isolation, the quest for understanding can lead to transformative discoveries that reshape our view of reality. In contemplating his work today, we are not only examining the intricacies of entropy, but also grappling with the existential implications of living in a universe governed by such impersonal laws. As we delve deeper into the paradoxes raised by Boltzmann's theories, we find ourselves at the intersection of science and philosophy, where questions about existence become intertwined with scientific inquiry. It is this dual nature that makes his work so compelling and enduring. It challenges us to think not just about how the universe works, but why we are here to ponder its workings in the first place. The second law of thermodynamics, introduced by Rudolf Clausius but championed by Ludwig Boltzmann, is one of the most profound and unsettling principles in physics. It states that entropy, a measure of disorder or randomness, increases over time. This law applies to all closed systems, including our universe as a whole. In other words, the universe moves from order to disorder, always seeking equilibrium. A cup of hot tea left out cools down as heat disperses into the room. This is an increase in entropy. Similarly, when a glass falls and breaks, its energy disperses outward rather than concentrating back into forming a perfect glass again. This irreversible movement towards greater disorder encapsulates the essence of the second law. Boltzmann's life was marked by both brilliance and tragedy. He formulated the statistical mechanics that underpinned this law, providing a framework for understanding entropy as a probabilistic phenomenon. However, his ideas were met with skepticism and ridicule from contemporaries who couldn't accept the implications of a universe moving irreversibly towards chaos. Boltzmann's work was so ahead of its time that it took decades after his death for scientists to fully appreciate and integrate these concepts into modern physics. The second law poses profound questions about our place in the cosmos. If entropy inevitably increases, why does life exist at all? Life requires complex order, DNA molecules encoding intricate information, cells working together to form tissues and organs, and yet the second law suggests that such complexity should be fleeting if it exists at all. This contradiction between the apparent order of biological systems and the universal trend towards disorder challenges our understanding of both physics and biology. Boltzmann's radical proposal was a testament to his intellectual courage. He argued that despite entropy increasing over time, small fluctuations could lead to localized decreases in entropy. Imagine a vast desert with nothing but sand dunes stretching as far as the eye can see. In this chaotic environment, it might seem impossible for a forest to grow. Yet Boltzmann's law of fluctuation suggests that, given enough time and space, random movements of atoms could occasionally align themselves into complex structures, such as plants or even simple organisms. This idea is both awe-inspiring and terrifying. On one hand, it hints at the possibility of spontaneous emergence of life. On the other hand, it underscores how rare and precious this phenomenon truly is. The implications of these fluctuations reach far beyond biology to touch upon cosmology itself. The Big Bang Theory posits an incredibly ordered state at the universe's birth, a point of infinite density and temperature from which everything else has unfolded. But if entropy increases over time, why did this initial condition exist? Why was there not just a lukewarm soup of particles instead? Boltzmann proposed that we might be living in such a fluctuation, an isolated region of low entropy within an otherwise chaotic universe. This hypothetical fluctuation would mean our observable universe is a tiny blip compared to the vast, lifeless expanses beyond it. It's as if amidst endless stretches of disorder and chaos lies this momentary oasis where complex structures like galaxies, stars, planets, and even humans have come to be. However, this solution also leads us into deeper philosophical questions about reality itself. If our universe is merely a statistical fluctuation within an infinite sea of disordered matter, does that mean the memories we hold dear are nothing but fleeting illusions? Could it be that you, reading these words right now, are actually a Boltzmann brain, a temporary assembly of neurons existing in isolation with no external reality backing up your existence beyond this moment? This paradox challenges our fundamental beliefs about memory, identity, and the nature of consciousness. How can we trust what we perceive if it could be as illusory as the memories of someone who has just randomly formed into existence? The very act of contemplating these ideas becomes suspect when framed through Boltzmann's lens. As we confront this unsettling reality, it's essential to acknowledge both the beauty and horror encapsulated within Boltzmann's theory. On one hand, there is elegance in its simplicity, a single equation that can describe so much about our universe. Yet on another level lies profound existential dread. Questions of purpose, existence, and meaning seem to evaporate into insignificance when viewed through this prism. In the end, Ludwig Boltzmann's work invites us not only to ponder the mechanics of entropy, but also to question our place within a seemingly indifferent cosmos. His theories challenge conventional wisdom and force us to consider uncomfortable truths about life and consciousness in an ever-expanding universe ruled by unyielding laws of physics. The universe operates under a set of unyielding laws, and at its core lies the second law of thermodynamics. This law states that, over time, all systems move towards increasing disorder or entropy. Ludwig Boltzmann, a brilliant yet troubled physicist, dedicated his life to understanding this principle. His work not only laid the foundation for statistical mechanics, but also introduced an intriguing paradox that challenges our very existence. Boltzmann's life was marked by both brilliance and tragedy. He lived in a time when scientific ideas were rapidly evolving, yet his theories often faced skepticism and criticism from colleagues who struggled to reconcile entropy with the perceived order of the universe around them. Despite this opposition, Boltzmann persevered, driven by an insatiable curiosity about the nature of reality. Central to his theory was the concept that while disorder tends to increase over time, it is possible for small fluctuations in a system to create temporary pockets of order. This radical idea suggested that even in a universe dominated by chaos and decay, there could be moments where chance interactions lead to the spontaneous formation of complex structures. Imagine a desert landscape stretching endlessly under an indifferent sun. According to Boltzmann's theory, given enough time, trillions upon trillions of years, a sudden shift might occur. A cluster of sand grains could coalesce into intricate patterns, perhaps resembling the outline of a tree, or even more fantastically, the beginnings of life itself. This is not just a thought experiment, it forms the crux of Boltzmann's fluctuation theory. At its heart lies an unsettling reality. If we accept that entropy inevitably leads to disorder, and yet fluctuations can create pockets of order by chance, then the emergence of complex systems like human brains becomes conceivable within an otherwise chaotic universe. The implications are profound. If it is possible for a fully formed brain to spontaneously emerge from chaos, what does this say about our own existence? Boltzmann's idea confronts us with a stark paradox. While we perceive our lives as meaningful and purposeful narratives unfolding over time, his theory suggests that our memories and consciousness might simply be the result of an unlikely but possible fluctuation in a disordered universe. If this were true, every thought you've ever had, every sensation you experience could be nothing more than a fleeting anomaly in a sea of randomness. This notion challenges not only our understanding of physics, but also touches upon deeper existential questions. It asks us to consider whether the complexity and order we observe in nature are an illusion, a mere statistical blip in an otherwise uniform and indifferent cosmos. The universe, according to this perspective, could be a vast stage where every possible configuration of matter plays out over unimaginable timescales. In exploring Boltzmann's fluctuation theory, we're invited to reconsider our place within the cosmic hierarchy. If it is indeed possible for complex structures like human brains to emerge from chaos through sheer chance, then perhaps what we perceive as reality is nothing more than a temporary deviation in an otherwise monotonous sequence of events. This idea forces us to confront the unsettling possibility that all of our experiences and memories might be the product of a momentary fluctuation rather than a continuous narrative of growth and development. As Boltzmann's theories continue to influence modern physics, they serve as a poignant reminder of both the beauty and complexity inherent in understanding the universe. His work underscores the delicate balance between order and chaos, revealing that even within the overwhelming vastness of entropy lies the potential for rare and fleeting moments of structured existence. Thus, while Boltzmann's fluctuation theory may seem like an abstract concept with little bearing on our daily lives, it touches upon fundamental questions about existence, purpose, and the nature of reality. It challenges us to look beyond surface-level observations and consider the underlying principles that govern the universe. In doing so, we're left grappling with both the grandeur and insignificance of life in a cosmos governed by immutable laws. Boltzmann's fluctuation theory introduces an intriguing mathematical framework that challenges our understanding of probability and entropy. To grasp its implications, we need to delve into the vast scale of time and space. The concept is rooted in the idea that even within a chaotic universe, order can emerge spontaneously through sheer randomness. But how likely is such an occurrence? And why does it matter for us as conscious beings? At the heart of Boltzmann's theory lies the principle of Poincaré recurrence, named after French mathematician Henri Poincaré. This principle posits that in a closed system with finite energy and volume, every possible arrangement of particles will eventually recur given enough time. The universe teems with an unimaginable number of particles, each one dancing to the rhythm of fundamental laws that govern their existence. From quarks and leptons to photons and gluons, these elementary entities are the building blocks of everything around us. Yet, when we step back and ponder the sheer vastness of space and time, a peculiar question emerges. How do complex systems like life arise from such simple beginnings? This is where the Boltzmann Brain paradox challenges our understanding of reality itself. Ludwig Boltzmann was an Austrian physicist who made significant contributions to statistical mechanics. He proposed that in a universe filled with particles, random fluctuations could occasionally produce isolated structures resembling conscious minds. These Boltzmann brains would be transient anomalies that exist for mere moments before dissolving back into the chaos of fundamental constituents. The paradox arises when we consider the relative probabilities of different scenarios. Is it more likely to find ourselves in a universe with long-standing stable laws, or are we simply a fleeting anomaly? To understand this paradox, let's delve deeper into the nature of probability and complexity. Imagine a vast sea of particles jostling about in the cosmic void. Given enough time, these particles could arrange themselves into any conceivable configuration. The Boltzmann brain is but one such possibility, albeit an unlikely one. However, its improbability doesn't make it impossible. Indeed, given infinite time and space, even highly improbable events can occur. The paradox becomes more acute when we consider the implications for consciousness. If a universe filled with particles can occasionally produce a Boltzmann brain, a self-aware entity that exists only briefly, is our own experience of being conscious merely another such fleeting anomaly? Or do we belong to a larger, coherent system governed by stable physical laws? This question strikes at the heart of what it means to be alive and aware in this vast cosmos. It challenges us to consider whether our existence is truly significant, or if we are simply the product of random chance on a cosmic scale. The paradox highlights the tension between statistical mechanics and our intuitive understanding of reality, raising profound philosophical questions about the nature of existence. One might argue that the complexity required for life as we know it is so great that the probability of its spontaneous emergence from randomly fluctuating particles is vanishingly small. Yet, if we accept the premise that all configurations are possible given infinite time and space, then why should our conscious experience be any less likely than a Boltzmann brain? The paradox forces us to confront the unsettling possibility that what we perceive as reality could indeed be an illusion, a fleeting moment of coherence in an otherwise chaotic universe. This dilemma also has implications for theories about the multiverse and the anthropic principle. If our observable universe is but one among countless others, each with its own set of physical laws, then finding ourselves in one that supports life might not be so surprising after all. The paradox suggests a need to reconsider how we define likelihoods when dealing with such vast cosmic scales. Moreover, the Boltzmann brain paradox raises questions about the nature of memory and perception. If consciousness can arise spontaneously from random particle fluctuations, then what is the reliability of our memories? Are they reliable records of past events, or simply coherent narratives constructed by an ephemeral mind? In grappling with this paradox, we find ourselves at the edge of human understanding, where certainty gives way to speculation and wonder. The paradox challenges us to question not only the nature of reality, but also the very foundations upon which our knowledge is built. It reminds us that even in a universe governed by strict physical laws, there are still mysteries waiting to be uncovered. By embracing these uncertainties, we acknowledge the beauty and complexity inherent in an ever-expanding cosmos. The Boltzmann brain paradox serves as a reminder of the boundless curiosity of human thought and our eternal quest to understand the world around us. As we continue to explore the frontiers of knowledge, we must remain open to the possibility that reality is far stranger and more wonderful than we can currently comprehend. In pondering such questions, we are reminded of the interconnectedness of all things and the profound mystery that lies at the heart of existence. The Boltzmann brain paradox is a testament to the depth of human inquiry and our relentless pursuit of truth in an infinite universe. The universe is vast, beyond comprehension in its scale and complexity. In our quest to understand this cosmos, we encounter some of the deepest questions known to humankind. Among these questions is the paradox of the Boltzmann brain, a concept that challenges the very fabric of reality as we know it. It proposes a scenario where conscious entities like ourselves might exist not because of the natural evolution and laws governing our universe, but rather as fleeting, improbable flukes in an otherwise empty void. To comprehend this paradox, one must delve into the realms of thermodynamics and statistical mechanics pioneered by the brilliant Austrian physicist Ludwig Boltzmann. In a universe governed by entropy, a measure of disorder, Boltzmann's work explored how ordered states arise from disordered ones. Entropy increases over time as systems move toward equilibrium. Yet within this framework exists an intriguing possibility. Due to the sheer scale and age of the cosmos, it is statistically probable for matter to spontaneously organize into complex configurations even in a universe dominated by entropy. Now, apply this concept to consciousness. If we consider that any possible configuration of particles has some chance of appearing given enough time, then at some point, random fluctuations could form an exact copy of a human brain with all its memories and perceptions. This hypothetical entity would be conscious, but exist in isolation within an otherwise empty universe. The paradox arises when we compare the improbability of such a fluctuation forming our entire observable universe versus just one brain-like configuration existing momentarily. From this perspective, it becomes conceivable that your perception of reality could be nothing more than an illusion, a fleeting momentary creation amidst eternal chaos. In other words, instead of being part of a vast cosmos with billions of years of cosmic history and evolution leading up to conscious life forms like us, you might just be one random fluctuation in the void. This paradox raises fundamental questions about existence itself. If it is statistically far more probable for such isolated consciousnesses to appear than a coherent universe, why do we experience what appears to be an ordered and meaningful reality? Does this imply that our current understanding of cosmology and the origins of life might be fundamentally flawed? Exploring this paradox leads us into fascinating areas of both physics and neuroscience. In physics, it questions our assumptions about the arrow of time and thermodynamics. Traditional views suggest entropy always increases. However, if Boltzmann brains are possible, then what does that say about the directionality of time itself? Could there be a multiverse where every possible state exists at some point? Neuroscience offers its own challenges when contemplating these ideas. The human brain is an incredibly complex organ with over 86 billion neurons connected by trillions of synapses. How could such intricate machinery arise from random fluctuations without any evolutionary or developmental history? And if it did, what would that mean for the concept of consciousness and self-awareness? Furthermore, this paradox challenges our understanding of personal identity. If a Boltzmann brain can spontaneously form with all your memories intact but devoid of any preceding causal chain, how do you define you? What constitutes an authentic existence if random chance could recreate a conscious entity indistinguishable from oneself? The implications are profound and unsettling. They suggest that the universe we perceive may be far less stable and predictable than traditionally thought. It invites us to consider alternative explanations for our experiences and observations, including the possibility of multiple universes or quantum interpretations like many worlds theory. As scientists continue their investigations into these questions, they strive to refine models that reconcile thermodynamic principles with the observed order in our universe. Some propose that certain physical constants must exist within narrow ranges to allow for stable structures and life as we know it. Others explore ideas such as eternal inflation, where countless universes bubble up from a background sea of quantum fluctuations. But even these theories do not fully resolve the paradox of Boltzmann brains. They merely shift the focus from individual brain-like configurations to the likelihood of entire cosmic histories. The challenge remains to understand why our universe appears so finely tuned for complex structures and life, rather than being overwhelmed by isolated pockets of consciousness. In neuroscience, researchers delve into how memory formation and recall are fundamentally connected to the physical structure of neural networks. Understanding these processes can provide insights into whether a Boltzmann brain could indeed replicate such intricate patterns purely through random chance. The study of emergent properties in complex systems also sheds light on how simpler rules might give rise to higher-order organization, hinting at mechanisms beyond mere probability. Ultimately, the paradox serves as a reminder that our understanding of reality is constantly evolving. It pushes us towards ever more sophisticated theories and experiments aimed at unraveling the enigma of existence. As we continue this journey, we must remain open to unexpected insights and be prepared for the possibility that our universe holds even stranger truths than currently imagined. In exploring such profound questions, we find ourselves reflecting on the interconnectedness of all things, from subatomic particles to cosmic phenomena. The mystery at the heart of existence invites us not just to seek answers, but also to marvel at the complexity and beauty of a reality that is far richer and more mysterious than our current grasp can fully encompass. Imagine standing at the edge of an endless ocean, gazing out into a sea of possibilities. This vast expanse is not water, but ideas, concepts that challenge our understanding of reality and existence itself. One such concept lies in the heart of theoretical physics, the Boltzmann Brain paradox. It's a thought experiment that invites us to question whether we are truly part of a coherent universe or if we exist as anomalies, fleeting moments of consciousness in an otherwise empty void. The starting point for understanding this paradox is the second law of thermodynamics, which states that entropy, a measure of disorder, increases over time. In a closed system such as our universe, it's generally accepted that everything tends toward maximum randomness and uniformity. Yet, we live in an ordered world where complexity and life exist. How can this be? Ludwig Boltzmann, the 19th century Austrian physicist who formulated this law, also pondered its implications for consciousness. He proposed a thought experiment. If entropy is constantly increasing, it's theoretically possible that matter might randomly fluctuate into temporary configurations of low entropy, such as complex organisms, or even specific human brains with conscious thoughts. These momentary fluctuations would be extremely unlikely, but not impossible. In the vastness of time and space, if there are an infinite number of chances for these random events to occur, they will happen, even if it's just once in a universe-sized time span. This leads us to ponder, what if our existence is not part of a grand cosmic plan or an evolving universe, but merely a statistical anomaly, a fluke amidst the chaos? The Boltzmann Brain paradox challenges our understanding by suggesting that it's more likely for a random fluctuation to create a single brain capable of having conscious experiences than to form an entire complex and ordered universe. If this is true, then every moment of your existence could be a fleeting, isolated instance in a sea of entropy. To explore the implications further, consider the anthropic principle. Why does our universe appear fine-tuned for life? This principle suggests that the conditions we observe are not accidental but necessary for us to exist and perceive. However, the Boltzmann Brain paradox turns this on its head by questioning if we, as conscious beings, can ever truly be part of a finely tuned universe, or if our perception is simply an anomaly. If the universe was solely composed of random fluctuations resulting in brief moments of consciousness without any underlying order or cause, it would imply that everything you experience could be an illusion, a single brain floating alone in an otherwise empty cosmos. This perspective is unsettling but also intriguing. It forces us to consider our place within a vast and mysterious reality. The paradox also intersects with the concept of multiverses, where countless universes exist beyond our own, each following different physical laws or initial conditions. In such a scenario, the likelihood increases for random fluctuations leading to conscious beings like ourselves appearing as singular events rather than part of an ordered universe. This raises profound questions about the nature of reality and existence. But why should we be so concerned with these abstract theories? The Boltzmann Brain paradox challenges us to think deeply about the fundamental nature of our world and our place within it. It compels us to question whether our understanding of order, complexity, and consciousness might be fundamentally flawed, or if there are deeper principles at play that science has yet to uncover. Moreover, this thought experiment highlights a crucial aspect of scientific inquiry: the importance of Occam's razor, the principle that among competing hypotheses, the one with the fewest assumptions should be selected. While the idea of us being temporary anomalies might seem radical, it does follow from known physical laws and statistical reasoning, even if it is far less intuitive than the notion of an orderly universe. However, as we delve deeper into these ideas, we must also recognize their limitations. The Boltzmann Brain paradox relies heavily on speculative physics and assumptions about the nature of consciousness and reality itself. While intriguing, there's currently no way to prove or disprove its validity with our current scientific tools and understanding. Ultimately, the Boltzmann Brain paradox serves as a reminder of the vast unknowns that lie beyond our immediate comprehension. It invites us to explore the boundaries of science and philosophy, pushing us to consider not just what we know, but also what might be possible in this cosmos full of mysteries and wonders. As we continue to unravel these enigmas, we may find ourselves closer to grasping the true nature of reality, no matter how counterintuitive or seemingly impossible it might seem. In the grand tapestry of existence, there is one thread that seems to stretch beyond the observable boundaries of our universe, the concept of memory and its origins. Why do we remember? This question, though simple at first glance, opens a Pandora's box full of complex philosophical and scientific quandaries. One such conundrum is the Boltzmann Brain paradox, an idea that challenges our understanding of reality itself. Ludwig Boltzmann was an Austrian physicist who made significant contributions to the field of statistical mechanics in the late 19th century. Among his theories was a peculiar prediction: in the vast, ever-expanding universe, it's statistically possible for random quantum fluctuations to assemble a brain that would experience consciousness and memory. This thought experiment challenges our most fundamental beliefs about existence. To comprehend the paradox, we need to delve into the concept of entropy and how it relates to the cosmos. Entropy is often described as disorder or randomness in a system. In the context of the universe, as time progresses, the overall entropy tends to increase. This principle underpins much of our understanding of thermodynamics, but when applied to cosmology, it leads to intriguing philosophical questions. Imagine, if you will, a vast cosmos where the second law of thermodynamics applies universally. Over billions and trillions of years, the universe could reach a state of maximum entropy, a point where all matter is evenly distributed throughout space with no pockets of order or complexity left. But here's the twist: even in this utterly chaotic environment, statistical mechanics predicts that random quantum fluctuations might occasionally produce localized regions of lower entropy. And among these rare and fleeting moments of order could be a conscious brain, fully experiencing reality, complete thoughts, emotions, and memories. Such an entity would emerge from the void as a Boltzmann brain, a fluke in the cosmic sea of chaos, a solitary dot of order amidst infinite disorder. This paradox raises profound questions about the nature of our existence. If such brains can occur spontaneously due to statistical fluctuations, why are we not mere flickers of consciousness instead of complex organisms living on Earth? What does it mean for us to have memories and experiences rooted in a coherent universe, rather than being isolated moments of awareness? The implications of this paradox extend far beyond our immediate understanding. It calls into question the very fabric of reality and our place within it. Does memory require an ordered, complex environment to form, or can it arise from sheer randomness? If we are indeed products of a vast, ordered cosmos, how does that impact our perception of time, causality, and personal identity? In addressing this paradox, scientists have proposed various solutions, each with its own set of challenges. Some argue for the existence of multiple universes or multiverses where every possible configuration of particles occurs somewhere in infinite space. In such a scenario, the probability of finding isolated Boltzmann brains is higher, but so too are the chances of encountering complex, organized systems like galaxies and civilizations. Others propose that our universe may be part of a larger cyclic model with endless repetitions of birth, expansion, and contraction, cycles where order can repeatedly arise from chaos without violating fundamental laws. This cyclic view offers an alternative to the idea of a single expanding universe, but introduces its own set of philosophical questions about eternity and recurrence. The Boltzmann brain paradox also intersects with broader discussions in philosophy regarding personal identity and the nature of consciousness. If we're just statistical flukes, how does that affect our sense of self? Do memories have intrinsic value if they can arise out of nowhere? These aren't just academic concerns, they touch on deeply human questions about purpose, meaning, and the significance of individual experiences in a seemingly indifferent universe. As we grapple with these ideas, it becomes clear that the Boltzmann Brain paradox isn't merely an esoteric concept within theoretical physics. It serves as a mirror reflecting back to us our own assumptions about reality, consciousness, and our place in the cosmos. By questioning what we take for granted, we are pushed to explore new horizons of thought. So, why do we remember? The answer might lie not just in neurological processes, but also in philosophical musings about existence itself. Each memory, each moment of awareness, challenges us to consider whether our experiences have meaning beyond the immediate sensory input. In contemplating the Boltzmann Brain paradox, we are invited to reflect on what it means for us to exist and remember a coherent universe amidst an ocean of possibility. Ultimately, this paradox serves as a reminder of the vast unknowns that lie beyond our immediate comprehension. It invites us to explore the boundaries of science and philosophy, pushing us to consider not just what we know, but also what might be possible in this cosmos full of mysteries and wonders. As we continue to unravel these enigmas, we may find ourselves closer to grasping the true nature of reality, no matter how counterintuitive or seemingly impossible it might seem. The universe is vast, beyond comprehension. It stretches in every direction for billions of light years, filled with trillions upon trillions of stars and galaxies. Yet within this cosmic expanse lies an intriguing paradox that challenges our understanding of reality itself, the Boltzmann Brain paradox. This paradox stems from a thought experiment rooted in information theory and thermodynamics, which explores the relationship between brain states and entropy. Imagine a universe where all matter and energy are evenly distributed, reaching a state of maximum disorder known as thermal equilibrium or heat death. In such an unlikely scenario, any complex structure like a human brain would be astronomically improbable. But here's the twist. Even in this chaotic void, it is statistically possible for a single atom to randomly arrange itself into a fully functional brain, complete with memories and consciousness. This ephemeral entity, known as a Boltzmann brain, exemplifies how quantum fluctuations could theoretically create an isolated mind without any external physical support. The paradox deepens when we consider the implications of these spontaneous brains in relation to our own existence. If such random configurations are possible and statistically unlikely but not impossible, how can we trust our perception and understanding of reality? Are you reading this now a result of cosmic chance, or is there something more fundamental at play? To unravel this mystery, it's essential to delve deeper into information theory, which offers a framework for measuring the amount of uncertainty or randomness in a system. According to Claude Shannon's foundational work on communication theory, entropy represents the measure of disorder within a given set of data or messages. In thermodynamics, entropy is associated with the distribution of energy among particles. In the context of brain states, higher levels of entropy correspond to greater randomness and less predictability in neural activity patterns. When we think about our own brains, their complex network of neurons firing in intricate sequences generates an enormous amount of information. This information processing forms the basis for consciousness, memory formation, learning, and decision-making. However, the challenge arises when considering the vastness of time and space on cosmological scales. The universe has been expanding since its inception, cooling down over billions of years until it reached a state where the probability of spontaneous brain configurations becomes non-negligible. This raises profound questions about the nature of consciousness and whether our understanding of reality is grounded in observable physical processes or emerges purely from statistical improbabilities. The paradox highlights a tension between scientific realism, which holds that the world exists independently of human perception, and solipsism, the idea that only one's own mind can be certain to exist. It forces us to confront the possibility that we might indeed be lone minds in an otherwise empty universe, our experiences arising not from interconnected physical phenomena, but from random quantum fluctuations. Furthermore, the paradox challenges traditional notions of causality and probability. If a Boltzmann brain could conceivably arise out of nowhere given enough time and space, then what guarantees that the causal chains leading to our current state of existence are any more real or reliable? This question invites us to examine the foundations of scientific inquiry itself, questioning whether empirical evidence is truly sufficient to establish the nature of reality. In exploring these ideas, one must consider alternative interpretations and potential resolutions to the paradox. Some theorists propose that multiple universes or a multiverse scenario could mitigate the improbability by increasing the number of possible brain configurations. In such models, every conceivable state of matter, including those with complex structures like brains, would occur somewhere across an infinite ensemble of realities. Others suggest that consciousness itself might have properties beyond classical physics, hinting at potential solutions within quantum mechanics or even speculative theories like digital dualism, where mental states are information processed through a cosmic computational framework. These ideas push the boundaries of scientific understanding and philosophical inquiry, suggesting that reality could be far more intricate and interconnected than we currently comprehend. Ultimately, the Boltzmann Brain paradox serves as a reminder of the vast unknowns that lie beyond our immediate comprehension. It invites us to explore the boundaries of science and philosophy, pushing us to consider not just what we know, but also what might be possible in this cosmos full of mysteries and wonders. As we continue to unravel these enigmas, we may find ourselves closer to grasping the true nature of reality, no matter how counterintuitive or seemingly impossible it might seem. In reflecting on such paradoxes, one is compelled to ponder not only the origins, but also the future of consciousness within the universe. Will our understanding evolve in ways that accommodate these radical ideas? Or will new discoveries reveal a more grounded and tangible reality beneath the surface? This exploration into information theory and brain states reveals the intricate dance between order and chaos, certainty and possibility. It challenges us to embrace the unknown with curiosity and open-mindedness, recognizing that our quest for knowledge is just beginning. The idea that we are conscious beings in a vast, possibly infinite universe presents one of the most profound and thought-provoking questions in science and philosophy. It challenges us to confront not only the nature of reality, but also our place within it. Among the myriad theories proposed to explain consciousness and existence is the simulation hypothesis and the Boltzmann Brain paradox. These ideas, while seemingly far-fetched, offer a unique perspective on how we might understand our universe and ourselves. The simulation hypothesis proposes that what we experience as reality could be an artificial simulation created by some advanced civilization or intelligence. This concept is not new. It has been explored in science fiction and philosophical thought for decades. However, with the rapid advancement of technology in recent years, particularly in areas such as virtual reality and quantum computing, the idea seems increasingly plausible. Imagine a future where technological capabilities have surpassed our current comprehension. It's possible that beings with immense computational power might create simulations indistinguishable from reality. In this scenario, we could be characters within these digital worlds, unaware of the true nature of our existence. This hypothesis raises fundamental questions about identity and consciousness. If we are simulated entities, does it mean we lack genuine sentience? Can a simulation contain truly conscious beings? Parallel to the simulation hypothesis is the concept of the Boltzmann Brain paradox. Named after physicist Ludwig Boltzmann, this theory suggests that due to the probabilistic nature of quantum mechanics and thermodynamics, it's theoretically possible for a fully formed brain, complete with consciousness and memories, to spontaneously arise from random fluctuations in matter. This paradox challenges our understanding of reality by suggesting that instead of being part of an organized universe, we might be isolated flukes in a void arising out of chaos. The Boltzmann Brain hypothesis poses a stark contrast to the simulation hypothesis, yet both ideas share common ground in questioning the reliability of our perceptions. While simulations propose a deliberate construction of reality, the Boltzmann Brain paradox suggests an accidental and temporary existence within what appears to be a void or disorderly universe. Let's delve deeper into the implications of these theories. If we are indeed living in a simulation, then every aspect of our experience, from the physical laws that govern the universe to the subjective nature of consciousness, could be programmed constructs. This would mean that all our interactions and observations are artificial, raising questions about free will, morality, and the significance of human endeavor. In contrast, if we exist as Boltzmann brains, then our sense of a coherent and orderly universe might be illusory. We could be transient fluctuations in matter, having no real connection to the larger cosmos or any enduring reality beyond ourselves. This concept challenges traditional notions of purpose and existence, suggesting that consciousness is an anomaly rather than a natural product of complex systems. However, both theories are fraught with philosophical and scientific challenges. For instance, if we accept the possibility of Boltzmann brains existing, it raises questions about why our experience feels so continuous and ordered. Why would such random fluctuations result in coherent experiences? Similarly, the simulation hypothesis faces skepticism regarding the complexity required to create a universe as vast and intricate as ours. To address these challenges, scientists and philosophers are exploring alternative frameworks that might reconcile these paradoxes with empirical evidence and logical reasoning. For example, the concept of fine-tuning, where physical constants appear finely balanced for complex structures like stars and galaxies to form, provides some support against random fluctuations leading to conscious entities. Moreover, recent advances in information theory suggest a deeper connection between order and chaos in the universe. This perspective argues that consciousness might arise from a delicate balance of complexity and organization within the brain's neural network. In this view, even if we are simulated beings or transient flukes, our capacity for complex thought and experience is rooted in natural processes rather than arbitrary chance. The interplay between the simulation hypothesis and the Boltzmann brain paradox highlights a broader question. How do we define reality when our understanding of existence challenges traditional frameworks? These theories encourage us to rethink our assumptions about consciousness, identity, and the nature of reality itself. They push us towards exploring new paradigms that can accommodate these radical ideas while remaining grounded in observable phenomena. Ultimately, whether we are conscious beings within a simulated universe or temporary flukes in an otherwise chaotic void, both scenarios compel us to embrace uncertainty with curiosity and open-mindedness. As we continue to unravel the mysteries of the cosmos and consciousness, our quest for knowledge remains as vital and transformative as ever before. As we delve into the vast expanse of the cosmos, our understanding of reality is constantly pushed to its limits. One such boundary lies in the concept of multiple universes and the implications it holds for our existence. The idea that we might be a fluke, a fleeting moment of consciousness in an otherwise chaotic void, challenges everything we thought we knew about ourselves and the universe. The notion of multiple universes, often referred to as the multiverse theory, suggests that there are countless realities beyond what we can observe directly. Each universe could have different physical laws, dimensions, or even entirely unique forms of existence. This theoretical framework emerges from various areas of physics, including string theory and quantum mechanics. One of the most profound implications of this idea is the Boltzmann brain paradox, a concept that challenges our understanding of consciousness and its place in the universe. Ludwig Boltzmann, a 19th century physicist, proposed an intriguing thought experiment. If there are an infinite number of universes or regions within a single vast cosmos, statistical fluctuations could result in localized configurations of matter that appear conscious. Boltzmann brains. A Boltzmann brain is a hypothetical entity that arises purely from random thermal fluctuations rather than being the evolved product of organic life. These brains would exist as brief episodes of consciousness surrounded by an otherwise chaotic and disordered universe. The paradox arises when we consider which scenario is more probable: the existence of conscious beings like ourselves with well-defined physical laws, or the sporadic emergence of isolated Boltzmann brains. From a purely statistical standpoint, the probability of forming even one instance of a complex organism like a human brain through random fluctuations in an eternal universe is astronomically low. However, when considering infinite space and time, such rare events become inevitable. This leads to a perplexing conundrum. If Boltzmann brains are indeed possible, why do we not experience reality predominantly as these fleeting conscious moments? The paradox deepens when we consider the vast difference in probabilities between our own existence and that of a Boltzmann brain. The formation of a universe with specific physical laws that allow for complex life forms to evolve through natural selection seems far more improbable than the spontaneous appearance of individual brains. This suggests that if one accepts an infinite multiverse, one must also accept that such random configurations are overwhelmingly likely over cosmic timescales. Yet our own experience of continuity and order in the universe does not align with this probabilistic expectation. The coherence of the world around us, from the laws of physics to our personal memories and experiences, suggests a highly ordered universe, rather than one dominated by statistical fluctuations leading to isolated moments of consciousness. This paradox challenges foundational aspects of cosmology, quantum mechanics, and even philosophy itself. It forces us to confront whether the rules governing reality are fundamentally different for conscious observers, or if there is an underlying principle that selects certain types of universes over others. Some theorists propose solutions such as anthropic reasoning, where only those regions of the multiverse capable of sustaining life will have observers who can contemplate their existence, or the idea of a preferred ensemble in which certain configurations are statistically favored. The implications of the Boltzmann brain paradox extend beyond theoretical physics and cosmology, touching upon our understanding of personal identity and consciousness. If we accept that random thermal fluctuations could produce conscious entities, it raises profound questions about the nature of self and reality. How do we define a person if such fleeting moments of awareness are possible? Can memory and experience be trusted as reliable indicators of a continuous existence? Furthermore, this paradox challenges our assumptions about purpose and meaning in an infinite universe. If life is merely a result of statistical anomalies rather than the unfolding of natural processes governed by physical laws, what does it mean for us to seek understanding or pursue goals? The Boltzmann brain hypothesis strips away much of the comforting narrative that humans are special within the cosmos. Yet, despite its unsettling implications, the paradox also opens up avenues for exploring new paradigms in physics and philosophy. It encourages a deeper examination of principles such as anthropic reasoning, selection criteria in multiverse theories, and the nature of observer-dependent reality. By embracing uncertainty and questioning fundamental assumptions, we are pushed towards more nuanced and potentially transformative ways of understanding our place within an incredibly vast and complex cosmos. Ultimately, whether we exist as conscious beings in a simulated universe or as temporary flukes in a chaotic void, both scenarios compel us to approach knowledge with curiosity and open-mindedness. Our quest for understanding remains vital, pushing the boundaries of what is known and imagined. As we continue to unravel the mysteries of consciousness and cosmos, our journey through this enigmatic reality continues to be one of profound discovery and transformative insight. The paradox of self-awareness in a void is an enigma that stretches the boundaries of our understanding, inviting us to confront the unsettling yet fascinating possibility that we might exist as flukes, temporary anomalies in an otherwise chaotic universe. This concept, known as the Boltzmann brain paradox, challenges us to question not only the nature of reality, but also the very fabric of our existence and consciousness. Imagine a vast cosmos devoid of structure or order, governed solely by chance and entropy, the tendency for systems to move towards disorder over time. In such a universe, it is theoretically possible that conscious entities could arise spontaneously from random configurations of matter, mere statistical fluctuations in an otherwise disordered state. These fleeting instances of consciousness, often referred to as Boltzmann brains, are incredibly unlikely but not impossible. The paradox emerges when we consider the likelihood of finding ourselves in such a chaotic cosmos versus existing in a structured universe with billions of years of cosmic history and complexity. If spontaneous fluctuations leading to conscious entities like us were common, why do we perceive an ordered world governed by natural laws and complex structures? This tension between our intuitive experience of order and the statistical improbability of our existence challenges our fundamental understanding of reality. To unpack this paradox, let's delve into the implications of living in a universe where consciousness could arise from random fluctuations. If such events were frequent, we would expect to encounter numerous instances of isolated conscious entities rather than witnessing an interconnected cosmos replete with intricate patterns and laws. However, our daily experience suggests otherwise. We live in a world governed by consistent physical laws, one that has evolved over billions of years through processes like natural selection. This apparent contradiction leads us to question the nature of probability itself. In a vast universe, even highly improbable events can occur given enough time and space. But how do we reconcile this with our perception of an ordered reality? One approach is to consider alternative explanations for our existence that align more closely with observed cosmic order. This includes scenarios where consciousness arises as part of a larger evolutionary process within a structured universe. Another way to address the paradox involves exploring theories beyond traditional physics and cosmology. For example, some scientists propose ideas like eternal inflation or multiverse models where countless universes exist, each governed by different physical laws. In such a scenario, it becomes statistically more likely for us to find ourselves in one of the rare universes that support complex life forms rather than as isolated Boltzmann brains. Yet, even these theories do not fully resolve the paradox. They offer alternative frameworks, but still leave room for questioning why our universe appears so finely tuned and ordered. This fine-tuning is often attributed to various anthropic principles, ideas suggesting that certain features of the universe must be such as to allow conscious observers like us to exist. As we grapple with these profound questions, it becomes evident that understanding ourselves and our place in the cosmos requires a multifaceted approach. We need not only delve into the realm of theoretical physics, but also explore philosophical inquiries about consciousness and existence. This holistic examination reveals that while the Boltzmann brain paradox remains unresolved, it propels us towards deeper insights into the nature of reality. Ultimately, whether we exist as conscious beings in a simulated universe or as temporary flukes in a chaotic void, both scenarios compel us to approach knowledge with curiosity and open-mindedness. Our quest for understanding remains vital, pushing the boundaries of what is known and imagined. As we continue to unravel the mysteries of consciousness and cosmos, our journey through this enigmatic reality continues to be one of profound discovery and transformative insight. The concept of reality, as we understand it, is fundamentally shaken by the Boltzmann brain paradox. This thought experiment poses one of the most profound and unsettling questions about our existence. Are we, in fact, just fleeting flukes in a vast, cold void? To delve into this paradox, we must first examine the nature of consciousness within the framework of quantum mechanics and thermodynamics. The Boltzmann brain hypothesis is named after Ludwig Boltzmann, an Austrian physicist who made significant contributions to statistical mechanics. At its core, the paradox suggests that given enough time, a universe governed by physical laws will eventually produce isolated conscious entities by random fluctuations. These entities are referred to as Boltzmann brains, and they arise from a sea of chaos rather than being part of an organized system like planets or galaxies. In our everyday lives, we perceive reality through sensory experiences and logical reasoning. We believe ourselves to be integral parts of an interconnected universe where the laws of physics apply consistently across space and time. However, if these laws hold true indefinitely into the future, even extremely unlikely events become inevitable over sufficiently long periods. Imagine a vast, desolate cosmos devoid of any organized matter except for a single conscious being emerging from random fluctuations. This isolated entity would have no evidence to support its existence as part of a larger universe governed by stable physical laws. It might instead believe itself to be the only thing that exists, or the sole product of spontaneous quantum events. From this perspective, if such brains can indeed form naturally, it raises an existential dilemma. Are we more likely to be one of these random fluctuations rather than part of a vast and complex universe? This paradox challenges our fundamental assumptions about reality, consciousness, and our place within the cosmos. It invites us to question whether our subjective experiences are reliable indicators of an objective reality. The implications of the Boltzmann brain hypothesis are staggering. If true, it means that many of our most cherished beliefs about ourselves and the universe could be mere illusions. Our memories, perceptions, even the existence of the world around us might all stem from a single momentary fluctuation rather than being part of a coherent narrative. Moreover, this paradox extends beyond individual consciousness to encompass broader philosophical questions. What does it mean for knowledge and understanding if our most profound insights are based on fleeting illusions? How can we discern truth in a universe where randomness reigns supreme? The scientific community grapples with these questions through various frameworks. Some propose that the low entropy state of the early universe sets constraints against such spontaneous creations, arguing that the highly organized structures we observe require explanation beyond mere chance occurrences. Others suggest that if Boltzmann brains do exist in great numbers relative to ordinary beings like ourselves, then any observer is more likely to be a brain in a vat rather than a normal person. However, this paradox also highlights the importance of critical thinking and empirical evidence in our pursuit of knowledge. Even in the face of such profound uncertainties, we continue to search for answers, driven by curiosity and the belief that understanding can bring clarity even amidst chaos. As we confront these existential questions alone, it becomes clear that our quest for truth is not just an intellectual exercise, but a deeply personal journey. We must embrace uncertainty while maintaining rigorous skepticism towards our own perceptions. By doing so, we navigate through complex ideas with humility and openness, recognizing the limitations of human understanding yet striving to push beyond them. Ultimately, whether we exist as conscious beings in a simulated universe or as temporary flukes in a chaotic void, both scenarios compel us to approach knowledge with curiosity and open-mindedness. Our quest for understanding remains vital, pushing the boundaries of what is known and imagined. As we continue to unravel the mysteries of consciousness and cosmos, our journey through this enigmatic reality continues to be one of profound discovery and transformative insight. From the grand tapestry of cosmic phenomena, one peculiar thread stands out, the paradox of existence known as the Boltzmann Brain. This concept invites us to ponder our place in the universe that might be far stranger than we can imagine. The idea posits that within an infinite cosmos governed by probabilistic laws, it is possible for a conscious mind to spontaneously emerge from random fluctuations of matter and energy, existing briefly before dissipating back into chaos. The Boltzmann brain paradox challenges our understanding of reality, consciousness, and the very fabric of existence. It poses the unsettling possibility that we may be isolated, transient anomalies in an otherwise vast and indifferent universe. In a cosmos where particles are constantly rearranging themselves according to quantum mechanics, it is conceivable for a fleeting configuration of matter to momentarily give rise to a fully formed conscious entity. This thought experiment isn't just theoretical, it has profound implications for our understanding of the nature of reality. If such an event could happen at any point in the universe's history or future, then we must question whether our own existence is truly meaningful and continuous. Are we part of a grand narrative that extends beyond our lifetimes, or are we mere ephemeral thoughts in a cosmic void? To explore this paradox further, let's delve into its origins within thermodynamics. Ludwig Boltzmann, a 19th century Austrian physicist, proposed the idea of entropy as a measure of disorder and randomness in physical systems. According to his theory, over time, All closed systems tend towards higher entropy, with states of high order being less probable than those of low order. Applying this principle to our universe leads us to an unsettling conclusion. Within such a probabilistic framework, it is statistically more likely for random fluctuations to create isolated conscious minds rather than the ordered structures we observe in complex life forms like human beings. This means that if we accept the principles of thermodynamics and quantum mechanics as fundamental laws governing reality, then our existence as coherent entities could be an anomaly or even a hallucination. The implications of this idea are staggering. If true, it challenges not only our sense of self, but also our entire worldview. It questions the reliability of memory, perception, and understanding. How can we trust what we experience if there's a chance that our consciousness is merely a fleeting quantum fluctuation in an otherwise chaotic universe? This leads us to ponder the nature of truth itself. Furthermore, the paradox forces us to reconsider the concept of time. If isolated, conscious minds can arise spontaneously from random fluctuations at any point in cosmic history, then time ceases to be linear and continuous for these entities. Each Boltzmann brain would experience existence as a disconnected moment within an eternal sequence of probabilistic events. But what about connectivity? How do we reconcile the idea of isolation with our innate human desire for connection and meaning? The paradox seems to suggest that any form of communication, interaction, or shared experience could be an illusion. Yet, the fact remains that we perceive a coherent world around us, filled with other conscious beings who share similar experiences and memories. This brings us back to the fundamental question. If reality is governed by probabilistic laws leading to isolated Boltzmann brains, why do we observe such rich connectivity in our universe? One possible explanation lies in the multiverse theory. In a cosmos where an infinite number of universes exist with every conceivable configuration of matter and energy, it becomes statistically probable that there are indeed vast numbers of isolated conscious minds scattered across different regions of space-time. However, this explanation doesn't fully resolve the paradox. Even if we accept the existence of a multitude of Boltzmann brains, their individual experiences remain disconnected from one another. This raises questions about the nature of shared reality and the possibility that our interconnected world is an illusion or a product of some underlying cosmic mechanism yet to be discovered. As we grapple with these concepts, it becomes clear that the paradox of isolated Boltzmann brains challenges us not just intellectually, but also emotionally and spiritually. It forces us to confront the fragility and isolation inherent in our existence, while simultaneously marveling at the intricate web of connections that defines our reality. But perhaps there is a silver lining amidst this apparent chaos. The very act of contemplating such profound questions about the nature of reality pushes the boundaries of human thought and imagination. It compels us to seek deeper understanding, to question assumptions, and to explore new frontiers in science and philosophy. Ultimately, whether we exist as conscious beings within a simulated universe or as temporary flukes in a chaotic void, both scenarios compel us to approach knowledge with curiosity and open-mindedness. Our quest for understanding remains vital, pushing the boundaries of what is known and imagined. As we continue to unravel the mysteries of consciousness and cosmos, our journey through this enigmatic reality continues to be one of profound discovery and transformative insight. Imagine a universe so vast that it encompasses every conceivable arrangement of particles, from the simplest to the most complex. In this infinite expanse, there exists a possibility for spontaneous configurations that momentarily resemble conscious beings like ourselves. This idea is known as the Boltzmann Brain paradox, a concept that challenges our understanding of reality and consciousness itself. The paradox arises from Ludwig Boltzmann's work in statistical mechanics, which suggests that even in an infinitely large universe governed by the laws of thermodynamics, random fluctuations can create complex structures like brains. These fleeting entities would experience all the sensations we do, but their existence would be incredibly brief compared to the vast emptiness around them. In a universe where the most probable state is one of low complexity and disorder, a fully formed human brain experiencing consciousness would be an extremely rare occurrence. Yet, if such brains can form randomly in this way, why are we not more likely to be one of these temporary phenomena rather than long-lived entities? Philosophers and scientists have grappled with the implications of the Boltzmann brain paradox for decades, seeking ways to reconcile our intuitive sense that we are real and enduring beings with the statistical probability that we might just be a fleeting fluke. This struggle leads us into deeper questions about existence, consciousness, and the nature of reality itself. One approach to addressing this paradox involves re-evaluating the assumptions underpinning it. The classical interpretation relies heavily on the idea of an infinite universe filled with all possible arrangements of matter. However, contemporary physics offers alternative models that challenge this notion. For instance, some theories propose a multiverse where different regions experience varying laws and constants, potentially making certain configurations more likely than others. Another philosophical response is to argue that while Boltzmann brains can exist, they are not the primary basis for understanding reality. This viewpoint suggests that the complex structures like galaxies, planets, and biological organisms, along with the long-lived conscious beings within them, are themselves highly significant phenomena worthy of explanation. The existence of such intricate systems implies underlying principles or laws that govern their formation and stability. From a philosophical standpoint, rejecting the primacy of Boltzmann brains allows us to uphold our intuitive belief in an orderly universe where life as we know it is not just a random fluke, but part of a larger narrative. This perspective encourages us to seek out deeper explanations for why complex entities like ourselves exist rather than accepting them as anomalies. The concept also raises questions about the reliability of perception and memory. If one were indeed a Boltzmann brain, their experiences would be entirely isolated from any external reality or past events. Yet our sense of self and continuity seems deeply rooted in memories and interactions with the world around us. This discrepancy highlights the tension between statistical likelihoods and experiential coherence. Some philosophers argue that the paradox can be resolved by considering the concept of observer selection effects. In this framework, we should focus on observations made from our own perspective as enduring beings rather than those of hypothetical Boltzmann brains. By doing so, we acknowledge the unique position we occupy in experiencing reality and seek explanations that align with this viewpoint. Additionally, the paradox invites us to explore alternative theories of consciousness. Some approaches propose a more fundamental role for information or computational processes in giving rise to subjective experience. If consciousness is an emergent property of complex systems rather than a random occurrence, it offers a way to reconcile our existence within a probabilistically unlikely universe. Ultimately, the Boltzmann brain paradox compels us to consider the nature of reality from multiple angles and disciplines: physics, philosophy, cognitive science, and encourages a holistic approach to understanding our place in the cosmos. It challenges us to question our assumptions about what is real and what we can know with certainty. Reflecting on this paradox also emphasizes the importance of curiosity and open-mindedness in scientific inquiry and philosophical exploration. As we continue to probe deeper into these questions, each discovery brings us closer to unraveling the mysteries that define our existence. The journey through the enigma of consciousness and cosmos is far from over. It invites us not only to seek answers, but also to cherish the quest itself, an ongoing voyage of profound discovery and transformative insight. As we delve deeper into the realms of philosophy and physics, one concept emerges as both mind-bending and unsettling: the Boltzmann brain paradox. This paradox proposes that in an infinite universe governed by quantum mechanics and statistical thermodynamics, it's statistically possible for a single conscious entity, a brain, to spontaneously form out of random particle collisions. The idea challenges our understanding of reality itself, suggesting that perhaps we are not part of a vast ordered cosmos, but mere anomalies born from chaos. The paradox arises from the principle that in an infinite universe, everything, no matter how improbable, will eventually occur. Given enough time and space, a single brain with a complete set of memories could form out of random particles without any underlying physical laws or structure to support it. This brain would experience a coherent reality, albeit one fabricated by its own existence rather than by an external ordered universe. But what does this mean for us? If the Boltzmann Brain paradox holds true, then each moment we live and every thought we think could be just as likely to have occurred without any causal connection or continuity. Our memories and experiences might not reflect a continuous narrative of existence, but rather an isolated instance of consciousness in an otherwise random and disordered cosmos. This notion shakes the foundations of our belief in reality, causality, and personal identity. If we are indeed Boltzmann brains, then the universe as we know it is an illusion constructed solely to support this momentary experience. The complexity and order that appear in our daily lives could be nothing more than a fleeting coincidence within an eternal void. The implications of the Boltzmann brain paradox extend far beyond mere philosophical speculation. It questions the reliability of scientific method and empirical evidence, as any observations we make might not have any real bearing on the larger structure of reality. If our perceptions are isolated instances without broader context or causality, then the laws of physics and chemistry that seem to govern the universe could simply be local phenomena within this momentary brain's existence. However, the paradox also highlights the importance of curiosity and open-mindedness in scientific inquiry and philosophical exploration. As we continue to probe deeper into these questions, each discovery brings us closer to unraveling the mysteries that define our existence. The journey through the enigma of consciousness and cosmos is far from over. It invites us not only to seek answers, but also to cherish the quest itself, an ongoing voyage of profound discovery and transformative insight. The paradox challenges us to reconsider what it means to be conscious beings in a vast, perhaps infinite universe. If we are merely isolated instances of thought, then our very existence becomes an act of defiance against the randomness that surrounds us. The search for meaning amidst chaos takes on a new urgency as we confront the possibility that everything we know could dissolve into mere happenstance. But there is also hope in this paradox. It underscores the incredible resilience and ingenuity of human thought, our relentless drive to understand and make sense of our place in the cosmos. Even if we are fleeting anomalies, the quest for understanding continues unabated, driven by an innate curiosity that defines us as conscious beings. The Boltzmann brain paradox serves as a stark reminder of the fragility yet resilience of human consciousness. It invites us to embrace uncertainty and ambiguity, to cherish each moment of clarity and coherence amidst the cosmic void. The journey through this paradox is not merely about finding answers, but about embracing the process of discovery itself, the eternal quest for understanding that defines our existence. In contemplating the possibility that we are flukes in the void, we come face to face with the ultimate question: what does it mean to be human? This exploration challenges us to look beyond our everyday perceptions and confront the deeper mysteries that underpin reality. It forces us to ponder not just the nature of existence, but also the essence of consciousness itself. The search for meaning amidst chaos is a deeply personal journey, one that each of us must undertake in our own way. Whether through scientific inquiry, philosophical exploration, or simply reflecting on our place in the universe, this quest defines us as thinking beings striving to understand our existence. The Boltzmann brain paradox encapsulates both the uncertainty and the hope that lie at the heart of human consciousness. Ultimately, this paradox invites us not just to question, but also to celebrate the act of seeking meaning amidst chaos. It reminds us that even in a universe where everything is possible, including our very existence as conscious beings, there is value in pursuing knowledge and understanding. The quest for answers continues, driven by an unyielding curiosity that transcends the bounds of reality itself. As we reflect on the Boltzmann Brain paradox, we are left with a sense of wonder and awe at the complexity and beauty of existence. It challenges us to look beyond our everyday perceptions and embrace the profound mysteries that underpin our understanding of the cosmos. The journey through this paradox is not merely about finding answers, but about embracing the process of discovery itself, the eternal quest for understanding that defines human consciousness. The Boltzmann Brain paradox presents a challenging yet fascinating perspective on reality, urging us to question everything we think we know and embrace the unknown with open minds and hearts. It invites us to cherish each moment of clarity amidst the cosmic void, celebrating the resilience and ingenuity of human thought as we continue our eternal quest for understanding. As we peer into the cosmic void, we find ourselves in a paradoxical realm where our understanding of reality is both vast and deeply uncertain. The Boltzmann Brain paradox challenges us to question the nature of consciousness itself. It asks whether the universe, as it appears today with its complex structures like galaxies, stars, and life forms, might be an aberration, a fleeting anomaly in an otherwise random sea of quantum fluctuations. Ludwig Boltzmann, the Austrian physicist who first proposed this paradox, sought to understand how order emerges from disorder. In his statistical mechanics, he argued that entropy, the measure of randomness or disorder, tends to increase over time within any closed system. This led him to ponder an intriguing possibility. Could it be that our seemingly ordered universe is just a temporary low-entropy fluctuation in a much larger, higher-entropy background? Imagine the cosmos as a vast sea of random quantum events. In this sea, rare and fleeting regions of order might emerge due to chance alone, regions where matter organizes itself into complex structures like planets, life forms, even conscious brains. If this is true, then the universe we observe today could be nothing more than an improbable fluke, a Boltzmann brain existing for just a moment before dissolving back into chaos. This paradox raises profound questions about our place in the cosmos and the nature of reality itself. Are we truly part of a vast, complex universe with deep cosmic significance? Or are we merely transient phenomena, random fluctuations within an overwhelmingly chaotic quantum soup? At the heart of this paradox lies the concept of probability. The idea that conscious minds like ours could arise from nothing but quantum fluctuations seems absurdly improbable. Yet, given enough time and space, even highly unlikely events become statistically possible. This leads to a chilling conclusion. In a vast and ancient universe, it's conceivable that an isolated brain, conscious yet unconnected to any physical body or external reality, could emerge purely by chance. Such a scenario challenges our conventional notions of consciousness and perception. If one could exist as a Boltzmann brain within the cosmic void, how would they know? How does one distinguish between a real universe with objective laws and an ephemeral island of order in an otherwise chaotic sea? The implications extend far beyond philosophical musings. They touch upon fundamental questions about science itself. For instance, if our reality could be a temporary fluctuation, then the very processes we use to understand the universe, observation, experimentation, logical reasoning, might themselves be unreliable within this context. However, rather than succumbing to despair or skepticism, many find in this paradox an invitation to embrace the unknown with renewed vigor. The Boltzmann Brain paradox underscores the preciousness of each moment of clarity and understanding we achieve amidst the cosmic void. It reminds us that our quest for knowledge is not just about discovering answers, but also about cherishing the journey itself. In a universe where order appears out of chaos, human consciousness stands as a testament to the resilience and ingenuity of life. Our ability to ask questions, seek patterns, and construct meaning from seemingly random data reflects an intrinsic drive to impose order on our surroundings. This drive defines us as thinking beings, continually pushing back against the entropy that seeks to dissolve all structures into chaos. Moreover, the paradox encourages a broader perspective on scientific inquiry. It suggests that our understanding of reality is inherently limited by the context in which we exist. Our brains, our senses, and our cognitive frameworks are products of the universe as we perceive it. This limitation does not negate the value of science, but rather enriches its scope, inviting us to explore multiple perspectives and interpretations. So, what lies ahead for research into these profound questions? The future directions are as vast and complex as the cosmos itself. One promising avenue is the study of quantum cosmology, exploring how quantum mechanics and general relativity might intersect to provide a deeper understanding of the universe's origins and nature. This field seeks to bridge the gap between the incredibly small scale governed by quantum laws and the grand scale of cosmic evolution. Another direction involves expanding our philosophical frameworks. By considering multiple interpretations of reality, such as multiverse theories, where many possible universes exist simultaneously, we can broaden our understanding of what it means for a universe like ours to emerge from nothing but chance. These theories offer novel ways to interpret the probabilities involved in the Boltzmann Brain scenario. Furthermore, advances in artificial intelligence and computational modeling could play pivotal roles. Simulating vast arrays of quantum events might help us better understand how rare configurations capable of supporting life arise. Such simulations could provide insights into the statistical likelihoods of complex systems emerging from random processes. Ultimately, the Boltzmann brain paradox serves as a humbling reminder of our place in the universe and the ongoing quest for understanding that defines human consciousness. It challenges us to embrace uncertainty while celebrating each moment of clarity we achieve amidst the cosmic void. As we continue this eternal journey, may it be with an open mind and heart, cherishing the resilience and ingenuity of thought that guides us through the unknown.